Okay, welcome, my friends, and we are streaming. Okay, can someone see me, hear me? Can I see a show of emojis there on the Web37 channel, please? All right, okay, excellent. Welcome, everybody. So let's talk about designing databases, right? It's something that is a lot of fun, and in today's exercise later tonight will be quite a bit of fun. We have to build a database for a simple application that's basically like a recipe book. Okay, so yeah, it's recommended that we start with a drawing of the interface, right? So we can just make a drawing and think of the minimum requirements for our application. How do we envision the application working, right? Something like super simplistic. Just put on the screen how you want it to kind of work, right? And then you start working on deciding what tables to use and what columns to use. So we're going to be talking about tables a lot and about columns a whole lot, okay? So this is the afternoon project. We'll come back to it if we have time, all right? And this here is the guided project, which we will be using for this lecture, okay? and these are the objectives here. We have objective 1, explain data normalization. Oh, that sounds really scary. And objective 2, the different table relationships that can happen. And objective 3, creating those table relationships using connects, right? So what this basically means is how to create foreign keys in our migrations, right? Cool. Okay, so the Slido is open and yeah, ready to rock and roll. So, okay, normalization. So what's this normalization thing? So basically, we want to be the data in the SQL database. We want it to be like super perfect. We don't want redundancies. We don't want Madrid spelled in 3 different ways. Okay, we want the table to make it easy for developers to pull data out of. Okay, a well-designed database makes life a joy, and a poorly designed database can wreck a company. Okay, a poorly designed database is going to unleash all kinds of hell, and the more time it passes, the worse it gets. Okay, if we have time, I will give you a few examples from my personal experience as a developer where bad database decisions nearly ruined a company. Okay, cool. So luckily for us, there's a bunch of relatively simple rules of thumb we can use to make our tables good and our columns good and avoid all that hell which I'm talking about. Okay, so we're going to start discussing these. We might read one line and then move to a different slide and start making drawings and things and then come back. And okay, so we are going to look at rules for tables, and once we're done with this, we're going to take a look at rules for columns. All right. Okay, ready to rock and roll? All right. Okay, so things we should do when we design tables. Okay. Everybody understands what it represents. Okay, so everybody means everybody in the company. Everybody in the company understands what the table represents. Okay, so that's kind of abstract, Okay. Number 2 is a little bit more, explicit, right? Like, for example, use plural for the table name, like cars, persons, or users, or things like that. And if you don't, at least be consistent with it. All right. Number 3, the table represents a subject or an appointment. Okay. So so those records inside the table are not super abstract entities. They really, really describe a thing or an appointment. Keep that in mind. And rule number 4, and this one is very important, rule of thumb number 4 in the yes department, use an artificial primary key of some sort. Okay, so primary keys are just columns or groups of columns that are able to uniquely identify a record in a table. So we can use columns that are already there. We don't need to have a dedicated synthetic primary key column, right? So we could use, say, the Social Security number column and use that as a primary key because it feels like it checks most the boxes for primary key, right? So Social Security numbers are unique. Okay, everybody has one. They can never change, whatever. Okay, but it's a bad idea. It's just a bad idea. So just use an artificial primary key like the ones we've been using, say integers, which auto-increment, and they can never be reused. The database takes care of business. Okay, and more importantly, normalization of SQL tables is a real science. Like, it's been studied for decades and decades and decades. Okay, there's a long laundry list of rules we have to follow to make our tables normal. Okay, quite a few requirements, as I say, right? And just by utilizing an artificial primary key column in our tables, we kind of like, we take care of half of the list, maybe even more. It's like we take care of a lot of bad stuff simply by having an artificial primary key. Just do it. Okay. Now, in the no department for tables, we cannot have duplicate columns, right? And by that, we mean columns holding identical kind of data point, right? So, for example, email columns like email 1, email 2, email 3. So that's bad. Don't ever do that. This particular defect is relatively easy to find and avoid, okay? Because these numbers kind of give it away. If we have columns which are for emails, and we have email 1, email 2, or maybe email primary, email secondary, right? So no one intends to create this defect, but it is very common. And why does it happen? Because of the product guy, of course. They always have to come into the room with some nasty requirement, right? And then, for example, we have an application with a users table, and there's an email column for the users table. Okay, so each user has a single email address which lives in the users table. End of story, right? Beautiful. But then comes the product person, and they be like, hey, we need to support a backup email. And then we'd be like, I don't know. Then we have a choice. We have the choice to introduce this defect, okay? Because it's easier to write a migration to add an additional column to an existing table. It's easier to do that than to extract the emails from the users table and create a dedicated table and move the data and right? So we know we're going to do the dark side thing, right? But of course we grab the product person and we make them swear over a stack of sacred texts and we make them swear that there never ever will be any other emails. Okay, and then of course, they'd be like, sure, no more emails. You got it. Okay, and then you create the lazy migration, and suddenly you have email 2, email 1, email 2 in the same table. You have this defect going on, which is going to make queries way more complicated. But karma always punishes us because the product guy inevitably comes back and be like, you know what? We need our application to support an unlimited number of emails for a given user. And then we feel like super stupid for having listened to the product person in the first time, right? And having gone the lazy route of creating duplicate columns in a table. Okay? Because what are we going to do now? Create 20 email columns, with the idea that they'll never need 20, right? So yeah. So stay away from this error. And I promise I'll shut up about it. Okay, I'm done with that. Next. Acronyms or abbreviations in the table name. Nothing like that, please, right? And this also has to do with everybody understands what the table represents. And please, no ambiguous table names, right? So if you have a table that's named data or even worse, table, it's like please don't, all right? So all of these rules are fairly easy to follow, right? And any questions regarding this? I'm looking at Slido. The Slido is clean. Okay. All right. So you believe me, huh? With a synthetic primary key and no duplicate columns? Yeah, we'll see. Please. When you run into this defect, send me an email. I'll love to hear about it. Okay. Next, rules for columns. Let's see if I can find them somewhere. Okay, cool. Here they are. Okay. Guess what? No duplicate columns like email 1 and email 2 and so on and so forth. All right? Or I'll come back to you in your dreams and torture you. Okay, next, rule number 2. No for columns. Please, no multi-part columns. Okay? This is a rule of thumb. It is not I guess there might be some situation where you are storing the full name of a user, like Joe Vega, for example. So this is Joe Vega's full name stored in a single column named perhaps full name. So depending on your application, it might be okay. But speaking in general, this is a multi-part column with 2 units of information in the same column, first name and last name. And normally you don't want that. A cousin of multi-part columns is multi-valued columns. All right? So those are columns which contain like a lot of information, right? So for example, we have a string with a comma-separated list of completely unrelated pieces of information. So the multi-part, well, at least it was the first name the full name of a subject, right? So this is like even more gross, right? So unrelated pieces of information jammed together into a single column, right? Number 4, calculated columns. Please, no calculated columns. When we were creating views yesterday, you saw how we can make queries that compute new artificial calculated columns. For example, we created a column that was the result of concatenating a first name and a last name, remember? Since you can do that with queries, don't ever create a new column that's the result of crunching numbers from other columns. Does that make sense? Whew. Okay, and another no. Okay, so non-primary key columns that depend on each other. So this one's tougher. So before we dive into that, I'm going to move over to Slido and see how we're doing so far. And Brennan is asking, if we wanted a user to be able to use multiple emails, would it be a good idea to create an emails table where you can just reference its primary key in the users table? And that is absolutely correct, right? So the reason there's no excuse to create duplicate columns is because we can do exactly, and we'll see more of this when we look at relationships, right? But if we have a users table with a primary key and name, right, and email, so in this world, this is fine. But as soon as the product person comes into the room, then this email column needs to go away, and we need to get an emails table ready, right? So this email tables, of course, has a primary key, has an email, and then has a user, perhaps underscore ID. All right. So for example, Brennan is user 1 with the name Brennan. Okay. And here there's an email, brennan@b.com, whatever. And the user ID is, of course, 1. And in this world, there's no limit to the emails Brennan might have, right? So we could create a second record on the emails table with perhaps Brennan's backup email. Okay, so this is Brennan's backup email. Oh gosh, I hope I'm not clobbering your name. And of course the user ID is the same because we are all the time talking about Brennan, right? So this is the primary key. This is the foreign key. This is the primary key on this table. Okay, so this is very flexible. All of a sudden, there's no limit to the number of emails a user can have in this application. Does that make sense? So this is how we fix the multi-part the duplicate column defect. Great. Okay, cool. All right, I know this is a lot of words. If you're falling asleep, just say something, okay? And I'll provide screenshots of these rules, right? And keep them close this afternoon. Keep them close during guided project. Brennan asks, how do we decide where to put the foreign key? Why place it in emails over users? Okay, so let's consider that for a second. As a rule of thumb, you could say the foreign key goes on the many side. What is the many side? Well, the relationship between these two tables goes like this. All right, it's this link on this side. This means one user can have many emails. That's what those symbols mean. Right? So this is the one, and this is the many. So perhaps you could use the rule of thumb of keeping those foreign keys on the many side. All right? But even if you can't remember the rule or the rule falls apart under certain circumstances, just think it through, right? So would it make sense to have let me just experiment. Would it make sense to kind of have an email underscore ID on? Would it make sense to have the foreign key on the user's side, right? And instead of this, would it make sense? Do you think? And have perhaps email 1, but then where do you fit email 2? Do you create another record for Brennan so we can put email 2? No, no, right? Do we create another column called email underscore ID 2? No. The thing is that as soon as you really draw it, right? So if you don't know, just make drawings like these and try to come up with an answer. The good news is defective designs will result in defects you can identify in the columns defects or the tables defects. Okay. Great questions. Cool. Oh, I'm talking a hideous amount. All right, back to 5. Back to this one. Non-primary key columns that depend on each other. This is some more subtle defect. Let's see if I can make a good job at explaining it. Do you remember how we said that a table, describes a subject or an appointment, right? And the subject of or the appointment is represented by the primary key. And then all other non-primary key columns are basically an attribute describing something about the primary key. And it makes absolutely no difference whether this is a foreign key or not. Okay, at the end of the day, all non-primary key columns are telling us a story about the primary key exclusively. But what happens if we have a column which, instead of describing something about the primary key, is actually having like a bad relationship, like it has a dependency on another column instead, right? So let me give you an example. Suppose imagine a column with an ID, a name, the boss, right? So this is one. The name of the worker of the user is Gabe, and Gabe's boss. This is a foreign key, so this is boss 23, right? So far, so good. So okay. It could be argued that maybe boss does not describe anything about me, right? So I feel there's kind of like a subtle defect here already, but let's set that aside. Okay. Imagine this. Picture this. Boss _ email. All right, so this is probably another foreign key pointing to the email 73 on the emails table. Okay. So check this out. Boss and boss _ email are coupled together, right? So if my boss ever changes, right? So this is if my boss ever changes, right? So perhaps there's a change in the chain of command, and suddenly all of a sudden I have a different boss, say boss 36. Boss 36. Because it is a different boss, obviously the boss _ email will have to be different, right? Will have to be the email of the new boss, perhaps email 34. Does that make sense? So the dead giveaway of this problem, where a column describes another column instead of describing the primary key, can be seen right here. When a value in a column needs to change, then immediately a value on another column also needs to change to keep the information logical and consistent, right? So this gives away this defect, this problem of non-primary key columns that depend on each other. All right, this is the toughest one by far we've seen today. Any questions? Oh, I talk so much, making myself sick. All right, everybody's dead. Okay, let's wrap it up and take a break, shall we? For the yeses, things that are desirable for columns. It is desirable to use unique names for things that appear once in the database. And we are breaking this rule left and right. Every time we choose ID as the name of a column, we're kind of breaking this rule, right? Because we're going to, ID would be used for IDs of all kinds of different tables, right? So it would be nice to have columns like user _ ID, email _ ID, animal underscore ID for those primary keys instead of just ID, 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 ID. Okay. Give you an example of a table that respects this criteria. The Triad playground, right? So this particular table has lots of, formal, normal defects in it, right? So I don't know. Let me see if we can find a defect, right? So it could be. I mean, there's the defect here with having the full name in the same column, right? There's more defects, right? So of course, these should be foreign keys instead of hard-coded countries. Otherwise, someone is bound to eventually enter a record spelling the country with a typo, right? So there's also multiple parts to no, not that one, to this one, perhaps. I mean, sometimes it is subtle, and sometimes these defects don't really matter that much for the application at hand. But this particular database is really good about keeping those column names unique across the database, right? So here we have, instead of just plain ID, we have customer ID, okay? And because we have because we're very consistent about it, other tables that point back to customer can use the same name, customer underscore ID, for this foreign key, and we know what it is. We know what it is. Okay? So customer ID is only used for that information, the ID of the customer. Okay? All right. More yeses. But again, watch the specification for the project carefully. You might be asked to create columns named ID in your projects. Okay, so you have to comply with the instructions in the READMEs, but just know that this is desirable. This is desirable. Now, more yeses. Columns represent a specific characteristic of the subject represented by the primary key. Holds a single value. We've beaten that horse quite a bit already. Number 4, the primary key represents the subject, and the non-primary keys describe the primary key. We've been over this, so I feel we're done. Any questions with all of this? Josh, that last no rule. Could we phrase this rule as no more than one link between any two tables? For example, the link should only be between the employee and the... I'm not so sure about that, my friend. I'll have to think on it. The link should only be between the employee and the primary key of the boss table. I don't know. It doesn't sound right, but I'll have to think it over a little more to see what you mean. Okay, my friend? All right, so that's it for the first objective. Okay, so these are simpler guidelines here on the training kit, right? Like each record has a primary key. No fields are repeated. Email 1, email 2, email 3. All fields relate directly to the key data, to the primary key. Okay, all non-primary keys describe the primary key. Each field entry contains a single data point. No multi-valued or multi-part columns, and there are no redundant entries. Okay, we avoid redundancy by this thing we're saying instead of hard coding countries here, right? So we avoid redundancy because each Germany you see is a duplicate, is actually a separate piece of information. Every Germany you see. Okay, so this redundancy will result in bugs eventually. Right. So you create a countries table, and then you refer to Germany by, I don't know, like country 21 or whatever its primary key might be. Okay. Rob, can I see the yeses for columns? Yes. Let me just let you take snapshots. Okay. So if you can take a snapshot of the yeses for columns. And in a second, I will switch over to yeses and noes for, for tables. Okay, and if someone would be an angel and just post those screenshots on the Slack channel, that would be super awesome. Okay, my friends, let's take a 5-minute breather and come back for relationships. Okay, so now let's take a look at Slido. No questions there, so everybody's caught up. And let's start working on a real example, and let's see how we can keep those defects away, right? So I'm going to show you something. I'm going to show you like a design for something. Let's see if I can find it. Where are you? Okay, there it is. Okay, cool. So imagine an app for quizzes. Okay, so here is the interface of the app. We are on a screen showing a quiz. Presumably there can be more than one quiz in the database. Okay? This particular quiz is called JavaScript Quiz and contains 3 questions. And then each question is associated with a bunch of possible answers, and then perhaps the user taps on the correct answer, and so on and so forth. All right, we're not going to over-engineer it. We're only going to study the relationships between the quizzes, the questions, and the options. All right, so I'm going to let you perhaps take another snapshot of this thing and maybe post it on the channel for reference, and then we're going to turn over to a clean sheet and start thinking about tables and columns and things, okay? So I'm going to move away from this thing. Oops. And there we go. Okay, so what tables do we need? What's the first table that comes to mind? I'm going to create a thread. Okay, if I'm able to type. I hope somebody's there. No one's posted the design. I hope someone's there. Okay, cool. Okay, so inside that thread, give me the name of the first column, the first table you want to build. No one? Questions. Okay, I like that. I like that. Questions. Okay, so what about questions? What else? That's it. Let's take another look at the design. See what it is that this has. So questions for sure. Those would be perhaps those that are in blue. Raw disclosure, importance of accessibility, right? And higher order functions are functions, right? Things like that. Yeah, I can totally buy that. I can totally buy questions. What else? Quiz for sure. Yeah, quiz. Right? So we want the database to be able to store a bunch of different quizzes with a bunch of different questions with a bunch of different answers. All right. Okay. Answers. Or, well, answer sounds like something which would be correct no matter what. Well, I don't know. Choices, perhaps? Options? I don't know. Yeah, but I agree. Something like this, right? And I totally agree. I totally agree. And Christina asks, is it like one table per component? No. You're about to see why not. Okay. And the next question, of course, is what columns do we want for? Nah, I know you're kidding. What columns do we want for quiz? Give me a bunch of columns. Don't over-engineer it. Let's just do the bare minimum to be able to do that design you see on the screen. Question type, max. So that would be the type of defect that says, okay, non-primary key columns must describe something about the primary key. So question type is not describing the quiz. All right. So we're going in order. We're starting with quiz, and you can't work in all parts at once. You have to settle for something. In this particular scenario, we're starting with quiz. Question ID, same thing. We're not We're not inside of here yet. We're not inside of here yet. We're here. Okay, so what columns do we want for the quiz? Quiz name, but more importantly even, quiz ID. Okay, so let's do it. I'm just going to do ID. You know it's a small defect because we're going to have ID columns all over the database describing different pieces of data. But I'm going to do that little defect just to make it easier on me, just so you be aware. But then someone is saying, where are you? Quiz name, exactly. Quiz, someone said quiz underscore name, perhaps. And yeah, I believe we're done. I'm looking at the design, and I don't feel like we need anything else than quiz name for now. Okay. What about questions? What columns do we want for questions? Okay, Max says number of questions. Yeah, but that can be computed. That can be computed with a query. That's an example. Number of questions is an example of something that is undeserving of its own column because it can be computed by counting rows, by aggregating information from different columns, and so on and so forth, right? So primary key for question, what else? Question name, okay. Question name or question text, perhaps I like better question text, okay. The text of the question, like, what is closure? That's the piece of information. And then you're saying quiz ID, okay, quiz ID. Quiz underscore ID. Okay, and this design is not. Okay, so the relationship here is that for one quiz, we can have many questions, right? So we have a one to many relationship going on between these two tables. This is the foreign key. Okay, on the side of the many, by the way, right? Yeah. But but hold your horses. We're not done here. This design is very limiting. Okay? Anyone can think of why this design would be very limiting? I mean, it looks good. It's nice and normalized, and I don't see any obvious defects, right? So what gives? Why would this be bad? No one? Sort of a tree, top to bottom. Only one direction. Okay, and that results in what? Why would it be stifling for questions to point back to the quiz they belong to? I feel like it's only natural, right? Multiple quizzes, yes. So if we want our application to be able to use the same questions across many quizzes, this would be stifling. Right? So imagine the scenario. We create a question. I'm going to delete this. We create a question record, right? Imagine record 23, right? With a question text. What? Actually, single quote. What is closure, right? Beautiful question. A question I hope to use often in many quizzes because it's so important. And then all of a sudden, I find that this particular question seems to always point back to quiz number 1, right? So isn't it a waste that if I want to create another quiz, I have to kind of like create an identical question, what is closure? So it can point back to a different quiz. See what's going on? So this kind of sucks, right? We live in a world of suck right now. Okay, so this is very stifling. So we gotta go back to the drawing board. I'm going to delete that column there, and we are going to think this through a little bit, right? I'm even going to delete this relationship, okay? So, okay, so did we discuss that tables normally contain subjects or appointments? What if we had a table which was kind of like an appointment between a quiz and a question? What do you say to that? Imagine a table called quiz_questions. Right? And this particular table might have a primary key, okay? And it might have a quiz ID, okay? And it might have a question ID, right? So it's a table that's made of a primary key, of course, and then a couple of foreign keys. This table is like appointments between different quizzes and different questions, because the sad reality is that here we actually have a many-to-many relationship, because we want questions to be used across many quizzes, and we want quizzes to have many questions. So it's kind of like, it's actually a many-to-many, which we never solve directly, but right. So this is kind of like a fantasy. We don't actually tackle this. We tackle it via an intermediate table which connects those two tables and makes appointments between them, right? So now we have a one-to-many relationship going on like so, all right? And also a one-to-many relationship going like so, right? So for example, we could marry the same question to any number of quizzes, right? So say we have the first record here points back to the first quiz, and we're talking about question number 3. Question number 3 is the awesome question, what is closure, right? And of course, we want to be able to use that in the second quiz, right? And we want to be able to use that in any quiz. So here we can record appointments between all of these quizzes and the what is closure question. Okay? And it doesn't mean that you can always solve all of your problems using this technique. It's just something that happens often. All right? Questions, my friends? Any okay, so yeah. Many-to-many relationship, that is how you solve it. Okay. Now, what about options? What columns do we want for options? ID for sure. I'm being lazy. I'm just gonna do it right. I'm gonna do quiz ID and question ID and option ID, right? So that way you can see more clearly, right, where these things connect. Oh, actually, I made a mistake. There and there, okay, and that and that. Okay. Okay. Option name. Option text, right? Like in question ID. Okay, / question ID. All right, I like that. Okay, cool. I like that. However, I don't know. If it was love at first sight. It was love at first sight. But then actually these questions, these options here, you know, can be involved to type, right? Why not have the ability to also use options across many questions, right? So there's that thought. There's that thought. What about this? Quiz underscore ID. Do we need that? We're not sure about this one. We're not sure about this one. Okay. But what about this one? Do we need that one? Yeah, questions. So many questions. Max says no. Chase says options as foreign key, having the answers in another table. Okay. So let's get rid of this. If we want to reuse, so my question now is, if we want to reuse options, if we want to reuse options across many questions, what is the answer here, right? Because it feels like one question should be able to have many options, right? That makes sense. But we also want options to be used for many questions. So again, we have a many-to-many situation going on. All right. And Josh says, hey, make a questions options table. Yes. Question underscore options. I like that. What columns do we need there? Okay. So, of course, we need a primary key. I'll be lazy there. And then we need question ID / option ID. Okay. Cool. I like that. What about quiz ID? Do we need how I guess my question is how are the options and the question options ever going to link back to the quiz? So I like these. I like the idea of having a one-to-many relationship going on there and a one-to-many relationship going on there, so we can avoid the many-to-many scenario, right? But don't we need a quiz ID there, or at least there, or both, right? It was denoted with a star, I think, right? Don't we need to link back to the quiz? What do you think? Matt says the options tie back into the quiz through the questions. Yes. So when we're working, we always tend to kind of like go overboard and add unnecessary foreign keys. There's no reason for the options nor the question options. There's no reason for those to link back to the quiz, okay? Because the questions, because the quiz questions link back to the quiz, okay? Okay, let me clean everything up. And there we have it. Okay, so let's clean up. So there's the quiz ID, and it's also there. All right. This is the question ID, and it's also there. Okay. And this is the option ID. What to do? A circle, perhaps. This is the option ID. With goes there, and here comes also the question ID. All right. Okay, so options are linked to question options are linked to questions, and questions are linked to quiz questions, which link back to the quiz. So at the end of the day, everything is connected. So fight the urge to create unnecessary foreign keys that are just not needed. All right. Okay, my friends. It's a little bit awkward. It's easier over Zoom, but yeah. So how are we feeling about and there can be many different scenarios. The recipes scenario this afternoon is not going to look exactly like this. It's going to be different, right? And do not try to visualize the whole thing at once. Start at a corner, start with a table, work with 2 tables at the same time at most, and start working your way through the design. Okay, looking at Slido, Max, avoiding redundancy seems impossible with dealing with many-to-many relationships. Even in quiz questions, you're still going to have repeated quiz IDs, question IDs. Oh, I see what you mean. Okay, so it does not matter. Okay, so that is not redundancy. If I have a bunch of records there and I'm pointing to the same quiz ID, a bunch of different questions, okay, that is not redundancy. Okay, it's not redundancy because this foreign key points to the one piece of data, Okay, so that is not considered redundancy. Okay. Redundancy is more like, repeating Germany. So this is an example of redundancy you definitely don't want. Okay. More questions. Okay, so when we come back from the break, we are kind of going through this exercise again. I'm going to give you a few minutes to think this through, and as soon as we have a schema we are happy with, we will jump into VS Code and apply it to a real project with Connects. Okay, so let's take a breather and see you in 5. All right, we are back in business. Looking at Slido, Max asks, and then when you do join queries and change ID to say country name, that's an okay scenario to have repeated Germanies because they're connected to a single ID. The thing is, that's the thing. That's a view. That's not the real table. That is just a visual. That's something artificial constructed with your query. It's not the underlying data. So it's fine to have a bunch of Germanies there because that is a view, not a table. So where we have to avoid redundancies at all costs is with the raw data inside the tables, with the records inside the tables. Then of course we will construct views with joins, and we will see repeated things left and right. That's just fine. Okay, great question. Cool. Okay, so I'm of a mind of starting a timer and let you munch on this. Pull out some, pen and paper and draw those tables, their relationships, the columns, okay? The same way we did before for the quizzes. And propose a bunch of tables and a bunch of column names to be able to render a screen with this looks like the name of the zoo, and this is the address of the zoo. Do not over engineer it. It's fine if the whole address goes into a single column, right? We know it might be a defect if our application deals with if addresses are central to and very important to our application, right? For some applications, it might just be fine to have all this in a single column. I don't know. Okay, and then we have a bunch of animals in this zoo, right? And animals have a name, and they also have a species. All right. So I'm gonna leave it in your hands. Start a timer. And we'll keep looking at Slack and yeah, make a physical drawing and take a picture of it with your phone and post it on Slack. Which I recommend that you do this afternoon too, so that we can criticize and review those designs, okay? So this is one of these things where feedback from someone who's done it up before is very important. Still waiting. No one? No one dares. The perks of being my favorite student forever until I find a new one. All right. Things are coming in. Okay, so all right, let's take a look. Okay, so Chase suggests like a zoo's table with a zoo ID, the name of the zoo, and the address of the zoo. I can buy that. And then what is this? An animals table with animal ID, the name of the animal, and the species. All right. And what is this here? Name ID, species ID. Okay, so there's a separate table for species, and that makes sense. So we don't have to have a lot of redundancies, right? So this is another Germany situation. If the animal has, if we have a lot of fish and it's spelled out right here, fish, right, inside the animals table, that's someone's going to enter a record at some point spelling fish differently or something like that, and that's going to make searches a nightmare. It makes sense to have a table for species. That makes total sense. This one I don't know what it is. Nice work, my friend. Okay, what other things we have here? Let's see. Okay. For example, so you're saying the zoo with ID, name, and address, of course. And then, so then animal underscore names, zoo underscore animals. Maybe just animals, right? Remember you keep those table names plural, so we would have zoos and animals probably. And zoo under. Okay. So a bunch of interconnected relationships here going on. So zoo animals is connecting the zoo with the animal. Here's the animal ID, the zoo ID, and then this would also need a primary key of its own. All right. Okay. I like it. What other things do we have? Brennan suggests species, pets, species name. Okay, so you have a species table. I like that idea to avoid redundancy there. And then the animals table. I like this. Okay, but the only thing that's missing is so you have the species, you have the zoos, you have the concept of zoos is what's missing. So you need at least one more table to hold those zoos, okay? Okay, anyone else? Let's see what we have here. Emily suggests, be consistent. If you're not going to use plural for the table names, do the same thing for all tables. So zoos plural, primary key, zoo name, address. I like that. ID, species, zoo ID. Okay, and names. What is names? Names is the species, right? I don't know. What is names? I'm not sure. So you can have the animal point to the zoo and have like a one-to-many relationship between the zoo and the animals. That could be, okay. Or you could make appointments between zoos and animals. It is true that an animal can only ever be in a single zoo at a time. So maybe we don't need that connecting table, okay. Then again, it turns into a philosophical discussion. Is the zoo ID an attribute of the animal itself? Right? Is this non-primary key describing the primary key? Is the zoo ID an attribute of the animal, an intrinsic attribute of the animal? I don't know. Okay. What other things do we have? Josh. Oh, Josh. Torturing me as usual. Zoos, animals, and species. Okay, so each animal points back to the species ID. I like that for sure. And then also points back to the zoo ID. This is what I'm not so sure I feel we could have a table to marry zoos with animals. And Corey suggests, okay, zoos, animals, species, and animals. And here you are marrying the zoos and the animals, it feels like, right? Animals underscore list underscore ID. I don't know, man. I don't know about this particular. I don't think we need this. If we get rid of this, then I like zoos. Species is also legit. Animals, the name and the species, right? So this would be, of course, a foreign key. All right, I like that. And here, so the criteria sometimes with connecting tables is to use names from both tables we're connecting, right? So if you're connecting zoos with animals, you would do zoo underscore animals. And that even reads nice. And here we create an appointment between animal ID, right, and the zoo underscore ID. I'm not sure whether that's what you meant, okay? But this could be a good connecting table to kind of like create appointments between zoos and animals. I like that. I would buy that. Okay. Anyone else? Okay, Max. You're not a doctor, right? For because you have the handwriting of one. Okay, so let's see. You did this on your computer, I bet. Okay. Maybe not. All right. Zoos. Animals. Okay. Names of animals. Is this a table name? Names of animals? Or just animals? Zoos. The connecting table. The appointment. Going in the right direction, I feel. Okay. What else? Oh, gosh. Yeah, mouse. Yeah, look. I apologize for that. Okay. I didn't mean to. Okay, so all right. So let's grab ideas from everybody. I say we do. Oh, let me just. Okay, let's do zoos table for sure, with ID and address. All right. Let's do species for sure, with ID and the name of the species. All right, that's for sure. And these are probably the simplest tables because they don't have any foreign keys. All they have is the primary key and then a hard-coded piece of information, right? So these are the simplest tables which don't have any entanglements with anything else, right? How about we now go with animals? Right? And an animal has an ID, has a name, right? And has a species underscore ID, right? So this is the foreign key. This is the foreign key pointing here. All right. So this table is a little bit more complicated because it includes a foreign key. There's a one-to-many relationship going on between species and animals. For one species, we can have many animals of that species, okay? So there's that one-to-many relationship going on there. Me like. And finally, I say we go with a more sophisticated example. And instead of having another foreign key there pointing to the ID of the zoo, instead of doing that, why don't we actually create a connecting table to create appointments and do actually zoo underscore animals. Note that I'm trying to be consistent about using plurals for all of those table names, right? And by using this convention whenever we join tables. And here, of course, its own primary key and then zoo underscore ID and also animal underscore ID. Okay, so here we are bringing, and these two, of course, are foreign keys, both of them, right? And of course here we're connecting there, and and here we are connecting there. All right. So it's a completely different kind of set of relationships than we had before, right? And the connecting table, no one says the connecting table may only ever have the foreign keys, primary keys and foreign keys, right? So in this situation, all we have so far is a primary key and a foreign key. But now that we have this like kind of like appointments table, we can do things like having timestamps with the date when the animal entered the zoo, right? And if the animal is ever transferred to between zoos, that is an advantage here to have this appointments table, right? So we can keep track of dates. We can keep track of date. We can date enter, date exit, and we can have the animal can move to a zoo and then back, and every time the animal comes back, it's a new record, right? A new appointment. I don't know if I'm making any sense, right? So I guess my point is, I guess we could point back to the zoo from the animals table, but that's nowhere near as flexible as having this connecting table, which can also record the date of the appointment and any other vaccination status of the animal when and many other things. Okay, but Enan says this totally makes sense. And that is so encouraging to me. Okay, friends. So now time to move into VS Code and kind of make it happen. All right. So could someone take a snapshot of this thing so we can refer back to it when we're working in VS Code? All right, excellent. Oh gosh, I'm there. Sorry about that. Cool. Okay, so this here is the project. It's already npm installed, and it's already pushing commits to a lecture branch, so you can reset to my branch if you need to. Then remember, if you pop your database open with SQLite and then try to reset to my branch, funky stuff might happen. I don't know. Okay, just in case. I'm mentioning just in case. Okay, so npm run server listening on port 4000, and let's see what we have here. The README, we took care of that already, so we're done here. Of course, it's always worth it. Take a quick look inside package.json, and the project has SQLite 3 and connects, and this library called connects cleaner, which is used for the seeds. Okay, whenever we seed, this little library helps clean up, empty out, and truncate those tables we're seeding to. Okay, otherwise we would have to migrate down, migrate up, and then seed whenever we want to reseed the database with fresh data, right? So this helps a little with that. And the usual helmet and express, of course. Okay, so nothing too exciting. Here's your ketchup script, of course. Okay, let's keep going. Let's take a look inside the connects file. All right. Now, the connects file, we actually need to change a little. All right, because in order to use foreign keys with SQLite, that is another step we need to do inside each environment we use with SQLite 3. Okay, so we're going to have to add stuff. Consider it boilerplate. We always need to do with SQLite, and whenever we have foreign keys we want to enforce. Okay, so I believe Objective 3 inside of Canvas contains this boilerplate right there. Okay, so see that? Needed when using foreign keys. Okay, so it's this pool key. So I'm just going to grab this pool key, slap it on in Slack also. and move it here, and just right after seats, I'm just going to plop it there. All right. Yeah, it's not that foreign keys don't work without it. It's just that they're not truly enforced. The database is not protecting its integrity. And by that, I mean with foreign keys set properly, the database will defend itself against inconsistent data. Right? For example, if we try to make a SQL operation to obliterate a zoo, the database can be like, not going to happen, because there are records in the database pointing to a zoo we are deleting, right? So if we have an animal pointing back, if we have an animal appointment, if we have a record here pointing back to a zoo, and then I go and delete the zoo, if that were to succeed, I would be left with broken data. I would be left with a record in this table pointing to a zoo that doesn't exist in the database, right? So that would be super gross. Similarly, if I come into species and I try and delete a species, right, while there are animals pointing to that species I'm deleting, the database ought to be able to defend itself and be like, I can't delete this species because there are animals pointing back to this particular species. So in order to preserve this thing called referential integrity, this cannot be allowed. Or, more dangerously, the deletion can be allowed to cascade, meaning if we delete the species, the database is going to take care also of deleting any animals pointing back to that species, right? Either approach results in either throwing an error or cascading the deletion. Either approach leaves the database with good data, with consistent data, which is what we want, right? So this cannot happen unless we turn on foreign keys like that. Okay, super important with SQLite. Okay, that was a mouthful. Okay, we're done with the connects file. Now let's take a look at the right. So we have a bunch of seeds going on, and this is going to be hinting at the migration we're going to be writing, because we have examples of the data, right? So for example, there's a seed for zoos, and you can see how a zoo, besides its primary key, it's going to have a zoo name and an address, like you said. And species, besides the primary key, species are going to have a species underscore name. I like that. Okay, so these are the simplest records, because these records do not have foreign keys. Okay, now take a look at animals. These seeds, each animal has an animal name and a foreign key pointing to the species ID. All right. So again, according to design, so we can tell these seeds match the design. All right. And then zoo animals is all about marrying a zoo and an animal. Right? So we can see those foreign keys going on, and we will come back to these seeds because we will need to know what column names to choose for the seeds to actually work, if that makes sense. All right. Now, what's missing is the database itself. It's not there anywhere. And we don't have any migrations either, so we better get to work writing migrations so we can actually do this thing. Okay, so who remembers the command to scaffold a migration? I'm looking at Slack. I'm creating a thread. Migration. How do I make a migration? And we're going to do all these tables in the same migration. Okay, Brennan delivers. So let's call it first migration. And this, I mean, this can happen. At one job, we had a first migration. We had a big migration. Okay, so let's take care of that. Thank you, Brennan. And now we have, thankfully, a migration file we can use to get things going. Okay. Now, as we said, we can create several tables using the same migration. There's no need to have a separate migration per table or anything like that. So we're just going to return connects.schema, and then we are going to start doing .create table a bunch of times, right? So create table, and then boom, boom, boom. So 4 times. There we go. All right. So this is the scenario, right? And down below the down function, we're kind of going to have the opposite. We're going to return connects.schema, and then jump to the next line to make it pretty, and then we're going to drop table if exists. Okay. And of course, that also needs to happen 4 times. And we can chain these, right? So we can do create table, yada yada, chain, another create table, chain, and same with the deletions. All right. So far, so good. Are you with me, my friends? Cool. Let's take a quick look. Make sure the application still compiles. It does. I guess it would only crash if we try running this migration. Now, in what order do we create these tables, and in what order do we destroy these tables? So what, in your opinion, should be the order of creation and the order of destruction? Based on my little propaganda on referential integrity, and you can't be doing stuff to records if there's other records pointing back to them. Create an order, destroy in reverse, biggest to smallest. Okay, so what order would that be? So where do we start? With, I don't know, with animals? What do we start with animals? Zoos first. Yes, yes. So I guess the rule of thumb is start with those tables without entanglements, without foreign keys. All right. So let's start with zoos and the table. Let's do table.increments. Although, as you know, we could do something like zoo underscore ID. All right. For tomorrow's sprint challenge, it is important that you follow the instructions to the letter, even if they somewhat contradict best practices. All right. So best practices, would be to do zoo underscore ID. You might be asked to create a table with an ID. Okay. So you have to always read the README very carefully. Okay. So yeah, what other columns do we need? Table.string. What do we need? The zoo underscore name, I think it was. I don't know, 128. Something like that. And do we want to add any constraints to this thing? We know by virtue of this little shortcut, this has a bunch of constraints on it from the factory. But are we wanting to allow any constraints here when we create records like this? No one has. Do we want to make this unique, perhaps? Maybe not, right? So why? I mean, conceivably, there could exist zoos with identical names. Why not? Any theories? Not nullable. Yes, I like that. Not nullable. Okay. So we want this record to be mandatory and not have a default value. All right. Cool. And any other? And I think we had tbl dot string zoo underscore address. Was it, or was it plain address? I can't remember. It's in the seed. It was just address, right? So we want to make sure that matches. And talk to the product person, right? It's ultimately a product person that decides how long a zoo name can be allowed to be, okay? Although you can always make a migration with the purpose of allow a particular column to support longer strings, right? And this can also be not nullable and whatever, right? And maybe unique, right? Whatever. Excellent. Yes. Okay. And we're done here. What about the next one? What should be the next one? The next column. Oh, and before we get into the next table, when should zoos be destroyed? First or last? Furious typing. Last, yes, we destroy in the reverse order. Okay, excellent. Okay, my friends, so what's the next table? Do we need a break? Maybe? I think it's past time. Animals, are you sure? Don't we have simpler tables with no foreign keys? I mean, we could do animals, but I kind of remember that animals actually has a foreign key. A foreign key pointing back to species underscore ID on the species table, right? So if we start work on animals, animals is going to have a foreign key pointing to a table that doesn't yet exist at this point. So it's probably going to be, yeah, let's go with species. Right? Let's go with species and table. And you know the drill. Okay. Why don't you do this work for me? Okay. Come on. And in the meantime, we can also destroy it next to last. Species. And these two are the interesting ones. This is where the new stuff really goes. This is the stuff with the foreign keys. It's very easy. It's just a small little thing, right? So perhaps we want to take a quick breather before we wrap up the class. Otherwise, our brain is going to melt, at least mine. Thank you, Brennan. My new favorite student. My new favorite student for all time until Corey comes along. Excellent. Okay, let's take a breather. Okay, we are back in business and working on the species table, and I'm going to steal code from you. Okay, so I will change this to be TBL. Increments species underscore ID and species underscore name. And does that match species underscore name? Yeah, that's beautiful. All right. So what about, what's next? Now let's do animals. We know animals has a column pointing back to species, but that is not a problem now. Cool. Okay, so what to do? TBL. Oh, why did I did that twice already now. Can someone care to take care of the first few columns at least? TBL increments and animal underscore ID. Okay, we can do that. Oh, we got goodies. Let's see, and Josh is saying, okay, cool. So animal ID, where's animal name? Yeah, let me steal from, I'll steal that one from Max. All right, so boom, okay. So excellent. So there's our primary key. Then each animal needs a name. Let's use strings, and it's required. Okay. And now Josh says, okay, but we also have a column, which is actually an integer in this particular, with the kinds of primary keys that we've been using so far. This is an integer for sure, called species underscore ID, right? Matching this one right there. And this integer is a little bit special because it's unsigned, meaning no negative numbers, only positive numbers. You know, there's a finite number of integers that can be used with this particular data type, and this is basically shifting them all to the positive side, right? So no -1, only 0, 1, 2, 4, whatever. Okay. And it's also required, so let's make it not nullable. And now the juicy part, right? The new syntax for today is references. References, right? References what? Well, references species ID. Okay. In table species. And this is a little bit too long and unwieldy, so I'm actually going to break it like this. All right. Okay, because we're not done. We still have to tell the database whether to cascade deletions or prevent them. All right, let me repeat. If we happen to delete a species, if we happen to delete a record here, how do we want the animal to react, pointing back to that same species? We want to prevent the operation, or we actually want the deletion of the species to succeed, and then also any animal of that species to also be deleted, right? So we specify that with chaining by on delete. On delete. So which do you prefer? More realistically, this is more realistic. Cause and error. This is more real life, right? People like to play it safe. But you could encounter cascade, and we can try them both. That's what migrations are great for. We can migrate with cascade, migrate down, change this to restrict, migrate back up, right? So for development, it's really nice to have proper down functions. So let's do animals there. And lastly, let's take care of zoo underscore animals. Okay. Now you know the syntax Now you know the syntax for referencing records from other tables, and this is quite a bit of typing that needs to happen, but it's, it's mostly copy and paste, right? It's mostly copy and paste from here, so yeah. Na 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 na. The latest and greatest is up. I can add it to the down function while I wait. Zoo_animals. Oh gosh, what's wrong with me? There we go. And I like this foreign key, this species ID. I mean, the species actually is an attribute of the animal clearly, whereas zoo ID, I don't know. I very much prefer this idea of making an appointments table. I better get started just in case. We don't need that. Animal underscore ID, I think it is. Oh, Josh. Josh delivers. And let me steal from Josh. And let's see if we can find any flaws. Okay. So the connecting table, of course, has its own primary key, and then all it has is a couple of foreign keys marrying the zoos and animals, right? So here we have animal ID references animal ID in table animals. Almost left that one. Excellent. On delete cascade, right? What about zoo underscore ID? Yeah, apologies, Josh. I obviously botched my copy and paste, right? References zoo underscore ID in table zoos. Okay. On delete cascade for now, although we will experiment with both. Well, what do you think? Is this migration going to run? Is the down function ready also? Brennan also delivers. Great work, everybody. Okay. Cool. Okay, so since we have seeds, taking this for drive is going to be really easy. All right, so let's run it. Connects migrate latest. Oh wow, it ran. What a disappointment. Seriously? There's the database inside the data folder, but the seeding will fail for sure. I want a bunch of bugs. What fun is life without bugs? Seed colon, what is it, run? I can never remember this one. It's either run or all. I don't seem to ever remember. I think it's run. And they ran? That's absurd. That is so disappointing. Okay. Anyway, we're out of the woods. Let's test if those foreign keys are actually enforced, right? So we have set deletions to cascade, right? Pretty fancy. So let's try that out by simply opening this database with SQLite Studio, right? So to get rid of this old stuff, yep, go away. This looks like something from yesterday. Let's pop zoos open and let's take a look at boom, 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 boom. I'm opening all four tables, putting them side by side, displaying the data. Okay, and I want also the SQL editor, and I will keep it floating above and something like this. Cool. All right, it's probably gonna disappear as soon as I click on the table, right? Yeah, I mean, gosh. Okay, so let's investigate these tables. Okay, so everything seems legit there, and there. I knew it. Disappeared. And there's our connecting table, and here's our zoos. Beautiful. All right, but the question is referential integrity maintained, right? So if I try and delete something, is the deletion going to cascade? Oh man, I apologize. Well, oh come on, just everything side by side. Boom, boom. Okay, a little bit narrow, but let's just delete, I don't know. Let's delete a species, right? So let's take a look at these animals. For example, Snuffles there. Oh gosh, where's Snuffles? Oh man. Snuffles there is a species of 1. And let's go to the species table and take a look at, okay, so that is star-nosed mole. Cool. So what would happen? These are the commands we just ran. Okay, these are the 2 MPX commands to migrate and seed. Okay. So let's delete the species and verify whether the deletion carries over everywhere. Like the animal gets deleted and any marriage of that particular animal with a zoo also gets deleted, right? So it's going to cascade is going to result in a bunch of deletions. So let's delete from species. Yeah, this is a real where ID species underscore ID equals 1, right? So let's grab all of that and run it, and whoa, check this out. Rows affected 6, no less, right? By just deleting this star-nosed mole whatever species, right? So if we start refreshing tables, obviously that record is gone from the species table. If we refresh animals, Snuffles is gone from there as well, right? If we refresh the marriages between the animals and the zoos, we can see Snuffles is gone from there also, right? So yeah, pretty brutal stuff. Pretty brutal stuff. Okay. So similarly, if we deleted a whole zoo, that should also obliterate any animals pointing back to that particular zoo, right? So for example, take a look. All these marriages of animals with the zoo with ID 2, right? So check out what happens if we delete from zoos where ID zoo underscore ID equals 2, right? Let's run that thing, and 8 rows affected, right? All of those marriages are gone because the zoo is gone, right? But of course, that didn't result in the deletion of any animals, all right? Just the marriages. Okay, so you can experiment and play with it a little bit. Any questions regarding referential integrity? The idea is that the information in the database be kept consistent. We can't have orphaned records, and we can't have records pointing to IDs that don't exist, right? Cool. So now I say, let's try migrating down. Okay, and migrating back up, but instead of cascade, we're going to Control D to replace all those instances of cascade. Let's replace them with restrict and see what that looks like. Okay, so let's migrate down before we get carried away. Okay, so mpx migrate roll back. Let's migrate down, and let's migrate back up, And now let's reseed. Okay. I'll stick there for a second so you can see those commands we ran. So we wanted a change to a migration to be taken in consideration. So of course we had to roll back the migration and then migrate back up. Okay. So this also tested that the down function ran without a hitch. Now let's refresh that data. Snuffles is back, star-nosed mole is back, and both zoos are back. Okay, so what happens if we try and delete this zoo now, right? If I try to run that now, we get this error, right? Error while executing SQL query on database zoos. Foreign key constraint failed, right? So this is the database using a more conservative approach to protecting referential integrity, preserving referential integrity. If this deletion on its own would result in weird data, or the database says, no, not going to do it. Okay. There are records in other tables pointing to this zoo you want to delete, so we're not going to allow it. And that is restrict. Okay. Questions, my friends? Okay, cool. So the afternoon project is one of the most fun in the unit, in my opinion. Okay, and it's totally different to what you'll do tomorrow in the sprint. So this is kind of like a one of a kind. This is your chance to design a database however you see fit. A few pieces of advice. Sometimes students go a little bit, simplistic and just, make this project with just a couple of tables, and that is not really possible. I do not believe this recipe book can be created complying with all these conditions. We definitely need more than 2 tables. Not a problem though, because much more commonly students will go like totally overboard or something, right? And make way too many tables. So I'm not going to tell you what tables and what columns. That's going to be you, but I recommend that you keep it in between 3 or 4 tables, right? So 4 tables allows more sophistication of the application. Okay, so maybe recipe. Maybe recipes have a bunch of steps, but maybe and there's also ingredients, and there's also quantity. I mean, there's all kinds of things. With 4 tables, it's going to be more powerful, more flexible. With 3, it's going to be more simplistic, more restricted, fewer, less powerful. Okay, honestly, try and keep it between 3 and 4. Right, 4 is probably the sweet spot. If you want to go overboard and do 5, well, yeah, it might be a little bit much. Okay, because I would much rather for you to stick to 4 and then be able to tackle stretch, because stretch is actually building the endpoints, and these endpoints are a lot of fun because in order to create these endpoints, you have to build model functions that perform joins, and it's a lot of fun, right? So, part of MVP is actually building those functions. But since you already have the migrations, you already have the database, you already have the seeds, you have everything. Just fleshing out a couple of endpoints is just a little bit more, and it's so satisfying to have working endpoints at the end of the day. Okay, so any questions regarding the afternoon project? Now, another thing, design your database using pen and paper, okay? And then use the help channel to post your design. That way, I can provide feedback and criticize and be a jerk. No, not that. I can gently provide constructive feedback. Okay, and no, seriously, allow me to comment on those designs. I'll try to get to them today. Worst case scenario, you will find your feedback tomorrow after the project is actually finished, right? But which won't be nearly as useful. But it's just that I'm packed with meetings for the rest of the day. Oh, that's so unfortunate. But do post your designs drawn with pen and paper like we did before. Post them on the help channel and engage in debates. And, well, I don't think, this primary key should be somewhere else, or we don't need that primary key, or maybe I have a different idea, whatever, right? So that's where the fun is, actually. Okay. Cool. Thank you so much for bearing with me. And no office hours today. I'll try to open Sprint Challenge early. No promises. I'll try. And worst case scenario, I'll see you tomorrow. Okay, Max. See you all tomorrow. Later. Bye-bye.